Hello there. So today we are going to take notes on distance. So yesterday I uploaded a video for you guys to watch on how to find the midpoint between 2 points on a graph, and you can find the middle by using this formula. Well, today we're going to talk about the distance formula, which looks like this. I know it looks intense, but it's not. It's actually really easy as you slowly start to combine things and get your answer. So this is going to be the formula that we're going to use for today to find the distance between 2 points. Instead of finding the middle, we want to find what the distance is, or the length of that line segment between 2 points. And typically, whenever we're looking for the distance between 2 points, that line tends to be a diagonal line. So let me find an example. Back on our parallel page, it's very easy to find the length of straight horizontal and vertical lines. We can just count how many units up or across they are, right? This length of this line is 4 units. The length of this line is 6 units because from this point to this corner up here, it's 6. It goes up 6 notches. But these diagonals, it's really hard to count how long they are because they're cutting through squares in a really weird way. And so we're going to figure out how we can find the distance of a line like this by just using a formula. So here's today's notes, and I have uploaded an empty version of this that you can fill out with me, or you can copy these down and pause when you need to. So the distance formula is the square root of the x2 minus x1 squared plus y2 minus y1 squared. And so when we use this formula, it's very important to be careful of our parentheses, to not get rid of them too soon, and to watch our signs. So for this first example, I've given you 2 points, and I want you to tell me what the distance is between these two. So I have labeled, as always, it's very important to label our x and y in both ordered pairs. This is x1, y1, first ordered pair, x2, y2, second ordered pair. So we're just going to plug in what we need to plug in. So up here, it's the x's that go together. So x2 minus x1. So that would be 10 minus 1 squared plus y2 minus y1, which is 3 minus 2. Right? Does everyone see where I got these numbers and I plugged them in here based on the labeling up top? Now I'm going to reduce what's inside of the parentheses first, right? Parentheses, PEMDAS. We're going to do parentheses first. 10 minus 1 is 9. 3 minus 2 is 1. So now that we've reduced what's inside, we're going to square that number. So 9 times 9 is 81. 1 times 1 is 1. Then we can add these two together, which is 82. And the last thing we have to do is find the square root of that number, which you would use a calculator to find, and the calculator will tell you that it's 9.1. So the distance of a line that has an endpoint of 1, 2 and 10, 3 is 9.1. That's how long that line segment is. And another way that you can do this, and I'm going to show you both on the next page, is to think Pythagorean theorem. So if you have a line segment and you're trying to figure out how long this line is, you can either use the formula we just did, or from those dots, you can create a right triangle. Just make a straight line that comes off here and comes off here, and you want them to meet up. And use the Pythagorean theorem, which is a squared plus b squared equals c squared. Make one of these straight lines A, make the other straight line B, and then you can solve for C. So if this is the formula, and I made my line A, my line B, let's count how many units each one is. So A is 1, 2, 3 units. So I made A 3. B is 1, 2, 3, 4 units. And we don't know C. So then we just plug in 3 squared plus 4 squared equals C squared. That's what we don't know, right? We're solving for it. So then I'll just start simplifying. Well, 3 squared is 9. 4 squared is 16. Equals c squared. Let's add these together. 9 and 16 give me 25, which equals c squared. And now to undo squared, we square root. They're each other's inverse operations. So these two cancel. leaving C completely by itself. But if you do it to one side, you have to do it to the other. So we're going to square root this side. The square root of 25 is 5. So in this example, C is 5. So you can either use the Pythagorean theorem if you'd like to graph the points and draw a triangle, or you can just use the formula if they gave you 2 points. So let's flip to the other page and look at 2 examples of this. Okay, so for this first example, find the distance between the 2 points, 4, 2, -3, -3. So you have 2 options. You can plug in these points that you know into your formula, which is really quick and easy, or you can graph them, make a right triangle, and use Pythagorean theorem. And I'll show you both ways. So option 1, let's look at our formula. I'm going to label my points x1, y1, x2, y2. I'll do this. Okay, so now they're labeled, so when I plug them in, I know where things go. So I'm going to do x2 minus x1. Hold on one second. Here we go. x2, which is 4, minus x1, which is -3. Keep in mind, the formula says minus x1. So my x1 is a -3. That doesn't mean that I only have to put -3, because that's very different. I have to put minus whatever that number is. And because that number happens to be negative, this is 2 negatives side by side, which is going to make a positive. Right? 2 negatives make a positive. And now let's look at the next one. y2 minus y1, which is 2 minus -3. And again, 2 negatives side by side become a positive. Don't just put 2 minus 3. It's y2, 2, minus y1, -3. All those signs have to go in there. So at this point, we're going to combine what's in the parentheses. So 4 plus 3 is 7. 2 plus 3 is 5. Okay, so now we have the square root of 7 squared plus 5 squared. Now we need to square these numbers. What's 7 times 7? And again, square means multiplied by itself. So these exponents tell you how many times to multiply this number by itself. So 7 is going to get multiplied by 7 2 times. 7 times 7 is 49. 5 is going to get multiplied by itself 2 times. So 5 times 5 is 25. Now we're going to add 49 and 25. And you can use a calculator if you need to, or you can count it. So what I would do is 49, and then I would just say 20. Let's just do the 20 first. We'll get to the 5 in a second. 49 plus 20 is 69. 49, 59, 69. And then I would add 5 to 69. And you can do it in your head like that if you need to. And that gives you 64. The last thing you have to get rid of is the square root to simplify this number. What is the square root of 64? It's 8. 8 times 8 gives you 64. So the square root of a number is one number multiplied by itself that will give you that number. And that would be 8. 8 times 8 is 64. If you don't want to use the formula like we just did, you can take that graph and make straight lines. So from these 2 dots, I would meet together to make a perfect right triangle right here. So make a line coming down and a line going across, and you've got a perfect right triangle. And that way you can count, well, how long is this line? Well, you just count these tick marks. It's 1, 2, 3, 4, 5, 6, 7. It is 7 places across, or 7 units across. And we can look over here and see that, because on the x-axis, this dot is over 3. And on the x-axis over here, this dot is over 4. So to go from -3 to +4, how far are these apart? Well, they're 7 apart. 1, 2, 3, 4, 5, 6, 7. That's a line that is 7 units across. And then to say, well, what's the difference in these y values between these two dots? From this dot to this dot, how far apart are they? Well, this dot is down 3, and this dot is up 2. So from -3 up to 2, it should be 5. 1, 2, 3, 4, 5. And you'll see that over here. We counted up, and we got 5. So this line is 7 units long. This line is 5 units high. You can make either one of those A or B. It doesn't matter. As long as the diagonal line is C. That's what we're solving for. So I made A 7, and I made B 5, and C is what I don't know. So I plugged it into the formula. A squared plus B squared equals C squared. I plugged in my A and B. 7 squared is 49. 5 squared is 25. And then I added those together. And if you see, we had a step that looked like that over here. We had 7 squared and 5 squared, just like here. We had 49 and 25, and I'm going to add those together and get 64. But to cancel the squared that's here, if I had 64 equals C squared and I need C by itself, I have to square root this side so that these two cancel each other out, and C is brought down. But if I square root this side, I've got to square root this side. And you'll see that we're getting to the same steps and the same answers. So both methods work. It just depends on which one clicks for you better. Let's do one more example together, and that'll be it for your notes today. Okay, so find the distance between these 2 points. Okay, so let's label them x1, y1, x2, y2. All right, so the formula tells us to do, let's see, x2 minus x1 squared plus y2 minus y1 squared. So let's do x2, which is 4, minus x1, which is -2. And we know 2 negatives make a positive. And then y2, 4, minus y1, which is -4. And we know 2 negatives make a positive. So now we can start combining what's in our parentheses and simplifying. 4 plus 2 is 8. I'm sorry, 6. 4 plus 4 is 8. So 6 squared, or 6 times 6, is 36. 8 squared, or 8 times 8, is 64. Well, 36 and 64 give me 100. And to simplify the square root of 100, you can plug that in your calculator. It's 10. 10 times 10 gives you 100. If you don't want to use the formula, you can make a triangle from your points. So I connected the 2 points that I had, and I made a straight line going down and a straight line coming out. And I said, okay, from this point to this point, like how long is that line coming down from this point and coming out from this point? How long is this line? It's 1, 2, 3, 4, 5, 6 units long. And I'm just counting my tick marks that are up above. And then from this dot down to where this dot is, that's 8 tick marks. So I chose this line to be A, this line to be B. So A is 6 and B is 8. It doesn't matter which one you make A or B, as long as the diagonal line is C. So when I plug them in, A squared, B squared is C squared, I can start simplifying. 6 squared is 36, 8 squared is 64. You'll notice this looks familiar. We're going to add them together, and then we're going to square root both sides to cancel that, and it'll look just like what we did up here. 36 plus 64 is 100. To cancel the squared, we're going to square root this side, but we also have to square root that side so that both of those cancel, and we can bring C down by itself. We're trying to get C by itself, and the square root of 100 is 10. And so both times we figure out the distance of this line segment is 10 units long. And the last little piece of notes that I put here for you is if you choose to make a triangle and use a squared plus b squared equals c squared, either straight horizontal or vertical line can be a or b. So either one, your horizontal or your vertical line, can be a or b. Notice that I capitalized straight. Okay, so either the straight horizontal, which is this way, or the straight vertical can be a or b. The straight diagonal is always C. So it does not matter which one of these you make A or B once you count how long they are. That doesn't matter. So you can either use the Pythagorean theorem if you'd like to graph it and visually see it, or you can just use this formula and plug your numbers in that they've given you and solve that way. Both ways work, and hopefully when we practice this in class, we'll figure out which way works better for you. Don't worry about memorizing this right now, but I do want you to have these notes for whenever we're doing practice in class. Thank you.